All right, this video is going to cover 7.2 in statistics, and we're going to talk about applications of the normal distribution. So in 7.1, we talked about what the normal curve is, and now we're going to talk about how we use it. So a z-score is a term you're going to start seeing. And the z-score is the number of standard deviations above or below the mean. So if it's above, you're going to have a positive number. If it's below the mean, you're going to have a negative number. So x is that number. So we plug x in, x minus the mean over the standard deviation tells us how many standard deviations above or below the mean that x is. If you're told it's the standard normal variable or not given a deviation and a mean, you use 0 and 1. So the z table, that's the table we're going to use, is table 5. So it looks like this. It's the really tall table. What this shows you, and it reminds you right on the chart, is the percent you get in here is the area to the left of the number. So that area of that purple shaded area. And then if you want the area to the right, you have to do 1 minus the percent. Now your z-score always has 3 digits, so like 1.45. The way you use the table is you find 1.4 here, so that's your ones and tenths, and then you find 0.05 up top, and you see where they meet. So they meet right here. So that would be 0.9251 is the proportion of data less than that. So that's kind of a quick thing. Now let's actually look at how we use it. All right. Oh, percentile. Whenever you're seeing the percentile, it's the percent of people less than or equal to that number. So the 20th percentile is saying 20% is to the left. All right, IQ has a mean of 100 and a standard deviation of 15. Find the z-score of someone with an IQ of 120. So that's our x. So we do x minus the mean over the standard deviation. And if you type that in the calculator, you get 1.33. So you're going to round to hundreds. Now we use that to find the percent of people less than 120. So we're going to 1.33. So we're going to use this table. We're going to find 1.3 over here on the side. So that's this row. Try to make it a little bit smaller. Okay. And then we find 0.03 at the top. So that's this column. And we're going to see where they meet. And it's at 0.9082. So 0.9082 or 90.82% of people have an IQ less than 120. Greater than 120, we just go one more step and we do 1 minus 0.9082, which gives us 0.0918 or 9.18%. So greater than, you just do 1 minus what you get. Now it says the 85th percentile. So that means in this table, we need to find as close to 85% as we can. Just trying to clear out here. So we're going to look in all these percents, and we're going to try to find 0.85. So right around here is where our 0.85 is. And the one that's the closest is this, because this is below by 0.15 and that's above by 0.08. So our corresponding z-score is 1.0. And then if we also go up, 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 we get 4 as our hundredths. So 1.04 is the z-score that goes with the 85%. So z equals 1.04. Now we're going to plug it into this equation and solve for x. So 1.04 equals x minus the mean over the standard deviation. So to get rid of that fraction, we multiply both sides by 15, and we get 15.6 equals x minus 100. And then we add 100 to both sides, and we get 115.6. So the IQ of the person at the 85th percentile is 115.6, meaning 85% of people have an IQ less than that. So you try example 2. The only thing that's different is the between here. So what you're going to do for that is you're going to find both proportions and then subtract them. So pause the video and try these, and then check in and see how you did. All right, less than 35. So 35 minus 38.72 over 3.17 gives us negative 1.17. So when I use the table, we're going to find negative 117, negative 1.1. And then we go over to 7, which is this one. So 0.1210. So this one. 0.1210 is the proportion that are less than 35. Then we're going to do greater than 42. So I want to get rid of all these colors here. Okay, so greater than 42. So first we have to do the math. 42 minus 38.72 over 3.17 gives us 1.03. Use the table, 1.0, and then 3 is this one. So we get 0.8485. And we want greater. So we're going to do 1 minus 0.8485. And we get 0.1515. So that's the proportion greater than 42. Now we're going to do between 35 and 40. So we have to do it for each. We already did 35 in A. So 35 is 0.1210. Now let's do 40. Oh, so we got 0.40. So I'm going to look for 0.40. Oops, that's this one, 6554. So 0.6554. And then between, we just subtract the two proportions. So 6554 minus 0.1210, we get 0.5344. And then the last question on this is find the height of a 3-year-old at the 20th percentile. So we want to find as close to 0.20 as we can. So let's see, 20. So we have those. So this one's the closest, 0.2005, which means our z-score is negative 0.84. So z equals negative 0.84. And then we plug that in. So x minus 38.72 over 3.17. Multiply both sides by 3.17, and we get negative 2.663 equals x minus 38.72. Add 38.72 to both sides, we get 36.06. And because all of our numbers are within 2 decimal places, we would leave our answer in 2 decimal places. So female baby, 3-year-old at 36.08 or 06 inches is the 20th percentile. So now let's look at another one. The scores earned on a math portion of the SAT college entrance exam are approximately normal, with mean of 516, standard deviation of 116. What scores separate the middle 90%? So we have a curve. We have 90% here in the middle. So if that's 90%, that means we have 10% in the purple areas. And since it's symmetrical, those are counted, those are in half. So we really have 5% in each symmetrical area, or in each purple area. So this would be the 5th percentile, and this would be the 95th percentile. So then we would use our table to look those up. So we're going to go look for 0.05. 0.05 And here's one where it's exactly in the middle. The red one is 5 above, the yellow one is 5 below. So you could pick either. You could do like, so your choices are negative 1.64 or negative 1.65. Or you could go in the middle and do negative 1.645. It doesn't matter. As long as you use one of those three, you're fine. So let's just say I'm going to do negative 1.64. That's the one I picked. So negative, oh my Lord, negative 1.64 equals x minus 516 over 116. And if I do that math out, I get 325.76. And SAT scores are always whole numbers, so if you said 326, that would be fine. If you left it with the decimal, that would also be fine, because you may not know that. Then we do the 95th percentile. So we're looking for 0.95 this time. And 0.95. My brain's having a moment. And we end up with the same issue. We're in between two. This time they're just positive numbers. So we've got the 1.6, 4, and 5. So this time I'll do the 1.65. Again, it doesn't really matter. I'll have checked for both. X minus 516 over 116. And then we do the math, and we get 707.4. So the range of scores, the middle 90% score between 326 and 707. That's how you would do that. Now, when you see this, Z sub alpha, alpha is this little fish-looking symbol. It just means the percent or proportion above X. So Z sub 0.5 is saying 50% above. Z sub 0.08 is saying 8% above. So if you were going to use the table, you would look up 92% because you look up below to use the table. So for example 4 here, find the value of Z sub 10. So 10 is to the right, which means 90 is to the left. So we would use our table and find 0.90, which is, this one's the closest. So we get 1.28. 1.28. Oh, goodness. So that's how you do all of these by hand. You can also use the calculator. So on your calculator, norm PDF is when you're looking for an exact, like what's the probability of this exact number? Look, sounds like a lot like binom. And then norm CDF is any range greater than, less than. And then if you're trying to work backwards, if you're given an area, you're going to do inverse norm. And I'll show you more on that in a second. So inverse norm asks you the area and then the mean and the standard deviation. Remember, if you don't know your mean and standard deviation, if they don't give you one, you use 0 and 1. And then your calculator would spit out the z-score. So let's do our inverse norm. Let's start with this. So if we were given z.10, to get this on your calculator, you hit second vars, just like we did for binom, except this time, PDF is 1, CDF is 2, inverse norm is 3. So second vars, inverse norm. So our area is the percent, which would be 0.9. And we don't have a mean and a standard deviation, so we use 0 and 1. And it spits out 1.28. So look, it gives us the same answer. Now, if you have some calculators will also give you an option of left, right, and center on there. If you have that option, then you could enter 0.10 and say to the right. Or this one, you could say 0.9 in the center. But if it doesn't give you that option, it's always to the left. All right, so now let's look at this. Norm PDF means we're going to put the x value, the mean, and the standard deviation, and that'll give us the percent at that exact point. CDF is a range. So if I say less than or equal to, our lower limit is negative 1e99. Really what that's saying is negative 0.0000000000001. Oops, nope, I lied. 1, the exponent's not negative. The exponent's not negative. So it's like saying negative 1 with 99 zeros, which you can't type infinity into the calculator. So that's just essentially how you type infinity. So it's saying less than means it goes down forever. And then if it's greater than, it goes up forever to positive 1 with 99 zeros. So let's look at how to use that. This is the same as example 2. So we've seen these numbers before. We're just going to talk about how to enter them in the calculator and then compare. So what proportion of 3-year-old females have a height less than 35? So less than is CDF. So we're going to do norm CDF. Lower means our lower limit is 1E99, and I'll show you what that is on a calculator in a second. Our upper is 35, because that's the biggest it can be. Our mean is 38.72, and our standard deviation is 3.17. So B, greater than 42, we would do norm CDF. But this time we're greater, so 42 is our lower limit, and we're going to go up forever. So we put 1E99 here. And then our mean and standard deviation are still the same. And then here we're between 35 and 40. So we do norm CDF, and we just put those two numbers as our upper and lower. And then find the height at the 20th percentile. That's our inverse norm, where our area is 0.2, and then 38.72, 3.17 is our mean and standard deviation. So that's how you type those in, or that's how you write those out. Now we're going to type them in. So for A, norm CDF, we do second vars 2, and then lower bound is negative 1, and the E is right above the comma. So to get E, you hit second comma. My Lanta. Second comma. And this is just how you do scientific notation in the calculator. So, oops. Your calculator will have a capital E, like a little capital E, and that's okay. So negative 1, second comma 99. And then you do the comma, type 35, comma 38.72, comma 3.17. Now, if your calculator lists it like this, that's how you do it with your commas. Otherwise, your screen might actually say lower, upper, mean, and standard deviation, and you just type them in there. Then we hit enter, and we get 1203. So that's what the calculator gives us, 1203. Let's go look at number 2. What do we get? We got 1210. So those are pretty close. They're not exactly the same because the calculator doesn't have to round, where we round. So I'd say that's pretty close. I would take either on the test. So let's try this one, norm CDF. And at any point, if you think you can do it, enter them on your own and then come back and check. So second vars. This one, our lower is 42. Our upper is 1E99. Mean is 38.72. Standard deviation, we get 0.1504. Then if I do it again, 35, 40, 38.72, 3.17, I get 0.5365. And then our inverse norm is 0.2, 38.72, 3.17, oops. And we get 36.05. So now if we compare those, on number 2, this one was 0.1515. So those, again, are pretty close. This one was 0.5344. and this one was 36.06. So that normal PDF approximates the normal curve, and you can do it either way. That is 7.2. Let me know if you have any questions.